Imagine a high-tech bank vault. It is protected by foot-thick steel doors, motion detectors, and a grid of glowing laser sensors tracking every inch of the hallway. Millions of dollars were spent to keep intruders out. But then, someone walks right up to the keypad and presses 1, 2, 3, 4, and the door swings wide open. The vault wasn't hacked. The owners just never changed the factory default passcode. This happens in the digital world every single day. When a massive data breach hits the news, we often imagine a genius in a dark room writing complex code to break through the walls. In reality, the attacker usually doesn't have to work that hard. They simply look for the easiest way in. In cybersecurity, this is called a security misconfiguration. For those looking to break in, it is known as the path of least resistance. These errors show up at every level of technology, from the databases to the web servers, which is why security experts rank this as the most common vulnerability found in systems today. It happens because of human error, a rush to get things working, or a simple lack of preparation. You can think of a computer system like a house. When the builder hands it over, it is in its default state. The doors are left unlocked so contractors can move in and out. But before you move valuables inside, you must harden that house by adding locks, closing windows, and setting an alarm. The biggest risk is an internal team that moves in, gets comfortable, and leaves the property on its insecure factory settings. Let's take a tour of our digital house to see where these vulnerabilities hide. They are often tucked away in the layers of the tech stack, hidden in the network wiring, the databases, or the apps themselves. The first place to look is the front door. Large-scale web servers are often designed to be extremely easy to set up. They ship with settings meant for speed and ease of use, rather than safety. Because of this, administrator control panels are frequently left exposed to the internet, protected by nothing more than the username admin and the password admin. Sometimes, developers even leave old testing scripts active, providing a quiet backdoor for anyone to use. Next, we can look at the storage shed in the backyard. In the digital world, these are the massive cloud storage containers where companies keep their files and data. Often, a busy engineer accidentally leaves permissions on a container set to public read, exposing millions of sensitive files. Securing these environments requires a 3-step checklist: disable public access, audit features, and change default passwords before the shed locks. Now we head back inside the digital house. Even if the doors are locked, a house can still be vulnerable if the internal alarm system fails or begins acting strangely. Imagine a home alarm that breaks, but instead of sounding a siren, it starts printing out the home's exact wire schematics and a list of everyone living there. In software, this is called a stack trace. When an application fails, it sometimes leaks a detailed log to the user. This message reveals the internal file structure and the specific versions of the database being used. Attackers use these messages as a digital X-ray. By seeing the internal map of the system, they can figure out exactly how to craft a second, more dangerous attack to steal information. Finally, we have to look at the scaffolding outside. While a house is being built, workers need development mode, tools and structures that make it easy to reach the roof and make repairs. Modern coding frameworks often leave these development tools and debugging settings active. When these are left on in a live environment, they disable the invisible safety rules that usually protect your browser from malicious instructions. Moving into the house without taking down the scaffolding creates massive gaps. It gives an intruder a ladder right up to the window, allowing them to walk right past your defenses. Maintaining all of this is a heavy burden for IT teams. They have to watch over networks, databases, and apps all at once. Humans are fallible. On a busy Friday afternoon, it is very easy for an overwhelmed person to simply forget to uncheck a single public access box. This creates a dilemma. Organizations have to choose between having a human manually check every single lock or using an automated system. Manual hardening is inexpensive, but slow and open to fatigue. Automated systems are faster and more reliable. Functioning like a smart home setup, they automatically audit every lock, window, and setting nightly, catching the small mistakes humans miss. While misconfigurations can happen at every level of the tech stack, they don't have to be permanent. With the right protocols, these gaps can be closed. Digital security relies on the simple, disciplined work of changing the factory locks and removing construction scaffolding. Taking the time to harden a system closes the path of least resistance and keeps the doors firmly shut.